Hey, hi everyone. So today's question is remove duplicates from the sorted array. So please pause the screen and go through the question and later on I will explain the question. So basically they are saying we are having array which is a sorted in ascending order and we have to remove the duplicates from that array. And they are mentioning that remove the duplicates in place. What is meant by in place is we don't have to use extra memory like initializing a array, hash set, hash map, anything which is used to solve this problem. We don't have to use an extra space. So let's get to the examples. So this is one array where are we are having the two unique elements, one and two, and you can see from left to right they are arranged into the ascending order. So this is one, this is two. And what we have to return? We have to return the length of all the unique elements. So by using this, which is k is a length of all unique elements. So they will assert that every element is a unique. So this is a second example. You can see 0, 1, 2, 3, and 4. You can see all the uh, unique elements, right? Like 0, 1, 2, 3, 4. So whatever are the occurrences for that, they are consecutive to each other. So whenever array is sorted, right, all the elements which are duplicates are consecutive to each other. So which might help us to solve this problem without using an extra space. So you can see 0 is added, 1 is added, 2 is added, 3 is added, 4 is added, and we have to return the length as 5. So the custom judge can take this length and figure out all the elements are unique. Okay. So there are two approaches. First is a brute force. Using extra space, anyone can solve this problem. But without using extra space, with a couple of pointers, we can solve this problem. So let's get to the pen and paper.
So suppose there is a one array, okay, and there is only one element. So into the array which is having a length one, so there is only one unique element, right? So that is a base case. So for a brute force solution, which will use the extra space. So suppose this is example. So what we can do, we can create a new array and we will add the first element as it is and we will iterate from the first element to the last element and we will check if a current element is not equal to previous element, then we will add it to the list. So this one is equal to the previous element, right? So we will go ahead, our pointer will go here and the current element is not equal to previous element, right? In this case we will add the current element. So this is a brute force solution. The pseudocode for this is, first of all, create an answer array and add the first element, append first element, and so let's iterate from first index to last. And if previous is not equal to current, then add it. So that is a brute force and time complexity will be linear because we are visiting each element once, and space complexity will also linear because we are using the extra space. Okay. So let me take this here. So that is regarding the brute force. Let's try to understand the constant space wala approach. Okay. So suppose this is an array. So suppose there is one pointer uh, like current pointer. So in this case also we will iterate from the first element to the last. So there is a one pointer current and there is one pointer also unique pointer u. So we will iterate from first index to the last index, and whenever current is not equal to the previous, right, we will add the current element to the uh, index of a unique element. So suppose this is the same array, okay, and what is the current value is 1 and which is not equal to the previous element, right? In this case we will not add it. The current will go here, and you can see the 2. 2 is not equal to the previous element, right? So in this case, we will add it here, and we will update the unique pointer. And as we have reached the end of an array, we will stop. So let's take another example: 0 comma 0 comma 1 comma 1 comma 2. So in this case, so first element will be always there. Unique pointer will be on the first index. Current pointer will be on the first index. So you can see current is not equal to previous element. That condition is false. So 0 is equal to 0. So current will go ahead. So you can see current is not equal to the previous. So in this case, we will add the current element to the unique index, and we will update the unique index by 1. So we will again update the current. Current will go here. So you can see current is equal to the previous. So we will again go ahead. The current will go here, and you can see current is not equal to the previous element. Matlab 2 is not equal to 1. In this case, we will add the current element to the unique index, which is 1, and we will update the unique pointer. Okay, and current will again go to the end of an array, and here we will stop. Okay, and 1 2 will be there. So you can see our unique pointer our unique pointer will be 3, right? Which is a all three unique elements, first three unique elements. So we have to return this. So the time complexity will be O of n, and space complexity will be O of n, which is constant. So in this case, we are not using an extra array. We are just segregating all the unique elements towards the left portion of an array. So the pseudocode for this is, so let's take a unique pointer, unique index equal to 1. Okay, and iterate from first index to last. And if current is not equal to previous, put current element on unique index and update the unique index. That's all. So at last, return the unique index, which is a number of a unique element. So that is the algorithm. So time complexity will be O of n, and space complexity will be O of 1. So that is pretty straightforward. Let's get to the coding of this solution.
As we have seen the pseudocode for this solution, so let's try to code this. So first of all, take a unique index which will be pointing to the 1. Then iterate from the first index to the last in a range of first to last length of numbers. And if current element is not equal to the previous element, if nums of current index is not equal to nums of current index minus 1, which is the previous one. In this case, add the current element to the unique index. So nums of unique index equal to nums of current index, and update the unique index and return the unique index. So the time complexity and space complexity is same, O of n, and space complexity is O of 1. So let's try to submit this. Yeah, it is working fine. So you can see this is pretty straightforward problem, and we are solving this with a constant space. Okay.